Okay, so we'll start with our next segment of stoichiometry, which is the percentages and concentrations. Okay, so we're going over the percentage yield, percentage purity, and we'll also go over the percentage compositions. Okay, in this particular lecture. Right. Let me just turn on the laser pointer. So this is like the last segment of our stoichiometry lecture series, and we have already covered empirical formula, molecular formula yesterday. So we are left with these three, and they are pretty simple. So we'll be going over these today. Okay, so first let's talk about percentage yield. So percentage yield basically measures the efficiency of a chemical reaction. It compares the actual yield to the theoretical yield. And it's important because reactions may not always go to completion and side reactions or losses can occur. Yeah. So for example, what this means is, okay, when you have a chemical reaction written in front of you, and when you actually perform that chemical reaction, so the yield of your products may be lower than the actual theoretical yield that you should get. So for example, if I have reactants, wait, let me just open the pen. So for example, if I have reactants A and B, right? And they react to form a product C and D, right? So this is the chemical reaction, for example. Now, now say I have 20 grams of A, right? We have 20 grams of A, and I have a molar ratio of 1:1, right? With A and C. So say that theoretically, if I do the molar calculations, I should get 50 grams of C, right? Theoretically, according to this chemical equation, I should get 50 grams of C. Okay. Basic molar ratio 1:1, but that doesn't mean, but okay, you'll get like 20 grams of C. Okay, obviously A and C are separate compounds, right? अगर A अगर ये दोनों same होते तो yes, you would get like 20 grams of A and 20 grams of C, but they're different compounds. So say that theoretically you get by reacting 20 grams of A, you get 50 grams of C, right? But actually, when you perform this reaction in the laboratory, so the yield of C that you get like 30 grams of C, right? When you perform this reaction practically. So some of the C is lost, or it's not really equal to the theoretical yield that you should get, right? So the percentage yield tells you the efficiency of a chemical reaction, or basically the ratio of the actual yield to the theoretical yield. So in order to find the in order to find the percentage yield, you'll just divide 30 grams, which was the actual yield, and you'll divide it by your theoretical yield, which is 50 grams. And like that, I think this is 80%. So you'll get, wait, let me just calculate. So I think this is 80%. No, sorry, this is 60%. Oh my God, math's flopping. So 60%. Okay, 60% is your percentage yield, right? So this is like a really, really simple way to explain कि percentage yield का मतलब क्या होता है, right? So hope you guys get the concept. अभी तक समझ आ
Yes.
गया? And Azlan आपको?
Yes.
Okay, so this will become even clear when we go over a question, okay? And we just look at an example. I think things will be much clearer. So uh, let's move on. So this is the formula for calculating the percentage yield. You basically divide the actual yield by the theoretical yield, and you multiply this fraction by 100 to get the percentage yield of your product, right? This is how you measure the efficiency of a chemical reaction. Okay, so let's go over a question. All right. So the question states that calcium carbonate is heated to produce calcium oxide, right? So calcium carbonate is heated to produce calcium oxide and carbon dioxide. So this is a decomposition reaction. And if we are just heating this calcium carbonate powder and it's giving off a white substance known as calcium oxide and carbon dioxide. Okay, so the question states that if 50 grams of calcium carbonate is heated and 28 grams of calcium oxide is obtained, calculate the percentage yield. So the question tells you that you have 50 grams of calcium carbonate that is reacting with, that is just being decomposed, thermally decomposed. And by using this 50 grams, you can calculate the theoretical yield of calcium oxide that you should get, right? And the question also tells you कि अच्छा हमने अगर इसको हीट कर दिया तो हमें ना मिला कितना 28 grams मिला सही है but mind you the actual yield will be greater than the sorry the theoretical yield is always greater than the actual yield ठीक है
28 और 50।
नहीं नहीं ऐसे नहीं करते ठीक है I'll tell you so right here सबसे पहले हमारा जो काम होता है ना you have to write the chemical equation for this reaction ठीक है it's not really a chemical reaction it's just heating of calcium carbonate so we have a balanced equation so it's very important that you write a balanced equation Aslan can you tell me what is a balanced chemical equation any idea Rafi आपको any idea
मैंने पढ़ा तो नहीं है, लेकिन इतना आइडिया है कि बैलेंस इक्वेशन मतलब जब इक्वेशन दोनों साइड से इक्वल होती है, जब रिएक्शन सक्सेसफुल होता है, मतलब एक केमिकल रिएक्शन।
close but not accurate मैं बताता हूँ so अच्छा सो इसमें ये होता है तो बैलेंस केमिकल इक्वेशन होती है ना उसमें यू शुड हैव द इक्वल लाइक नंबर ऑफ एटम्स ठीक है सो फॉर एग्जांपल यहाँ पर कैल्शियम का एक एटम है राइट कार्बन का कितने एक एटम है ऑक्सीजन के तीन एटम्स है राइट सो यू शुड हैव द एग्जैक्ट सेम नंबर ऑफ एटम्स ऑन द अदर साइड सही क्योंकि वी हैव टू फॉलो द लॉ ऑफ कंजर्वेशन ऑफ मास इन द एंड सो you have one calcium atom and you check on the other side product side to be a calcium atom है so that's okay carbon का एक atom है on the reactant side so carbon का एक atom on the product side so that's okay too wait let me just open okay so we have carbon का एक atom and then oxygen के we have three atoms and on the product side we have one and two and that makes three atoms of oxygen so this is a balanced chemical equation that's very important जब भी आप लोग मोलर कैलकुलेशंस कर रहे हो यू नीड टू हैव अ बैलेंस्ड केमिकल इक्वेशन सही है ये हमेशा अपने दिमाग में बात रखनी ऑल्दो आई डोंट नो कि रिसेंटली ओ लेवल्स के अंदर क्या ट्रेंड चल रहा है लेकिन हमारे टाइम पे दे यूज टू गिव बैलेंस्ड केमिकल इक्वेशंस ए लेवल्स में दे रिक्वायर यू टू बैलेंस द केमिकल इक्वेशन योरसेल्फ राइट बट इन ओ लेवल्स it's usually a balanced chemical equation. Okay, so the next step is to calculate the molar masses. सही है सो हमारे पास कितना था कैल्शियम कार्बोनेट की मोलर मास आ गई 100 यू जस्ट ऐड अप द इंडिविजुअल एटॉमिक masses ऑफ द एलिमेंट्स 100 grams per mole कैल्शियम कार्बोनेट की आ गई कैल्शियम ऑक्साइड की 56 ग्राम per mole आ गई right so you know the molar masses now okay so now we have to calculate the theoretical mass of calcium oxide that is produced right so so according to this according to this equation, if you have 1 mole of calcium carbonate, you should get 1 mole of calcium oxide, right? So 100 grams, that is basically 1 mole of, that is basically the molar mass of calcium carbonate, will react to produce 1 mole of calcium oxide, that is 56 gram of calcium oxide, right? तो इसका मतलब अगर हम 100 ग्राम हमारे पास कैल्शियम कार्बोनेट हो तो कितना प्रोड्यूस होना चाहिए कैल्शियम ऑक्साइड 56 grams ठीक है so the theoretical mass is जो प्रोड्यूस होनी चाहिए 1 मोल रिएक्ट करके, that should be 56 grams, right? So theoretical mass कैसे calculate करेंगे? Just divide 50 grams of calcium carbonate, ठीक है, and divided by 100 grams per mole, that is your theoretical mass, क्योंकि 50 grams हमें यहाँ पर दिया था calcium carbonate, right? And you divide it by 100 grams, that is your, so you get like 0.5 moles of calcium carbonate, right? So you should get 0.5 mole of calcium oxide here as well. कि हमारा जो 0.5 mole of calcium carbonate is reacting here, and it should produce 0.5 mole of calcium oxide, right? So
56 डिवाइड नहीं होगा?
नहीं 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 नहीं, 56 मैं बताता हूँ कब डिवाइड होगा। अभी ये तो बचल गया ना कि सबसे पहले हमने कैलकुलेट करना है कैल्शियम कार्बोनेट के मोल्स कैलकुलेट करने हैं जो रिएक्ट हो रहे हैं। सो वी जस्ट डिवाइड 50 ग्राम्स जो हमारे पास था कैल्शियम कार्बोनेट, एंड डिवाइडेड बाय इट्स मोलर मास, सो यू गेट 0.5 मोल। सो 0.5 मोल कैल्शियम कार्बोनेट रिएक्ट करके यू विल गेट 0.5 मोल ऑफ कैल्शियम ऑक्साइड, क्योंकि 1:1 है। ओके, सो नाउ वी कैलकुलेट द, देखो यहाँ लिखा हुआ है सिंस 1 मोल ऑफ कैल्शियम कार्बोनेट प्रोड्यूसेस 1 मोल ऑफ कैल्शियम ऑक्साइड, सो 0.5 मोल ऑफ कैल्शियम कार्बोनेट टाइम्स 56 ग्राम्स, ठीक है, क्योंकि वही 0.5 मोल है ना, तो उसका हम मल्टीप्लाई कर देंगे विद द मोलर मास एंड यू गेट 28 ग्राम्स ऑफ कैल्शियम ऑक्साइड। सही, दैट इज योर थियोरेटिकल यील्ड। नाउ इत्तेफाक से हमारी जो एक्चुअल यील्ड है और जो थियोरेटिकल यील्ड है वो बराबर हैं, ठीक है, they're both the same. So 28 grams divided by 28 grams, and that gives you 100% percentage yield. So yeah, that's not really possible, लेकिन theoretically इन्होंने question for the sake of the question इन्होंने 100% दे दी। सही, so I hope you guys get the idea कि किस तरह से calculate करते हैं percentage yield.